Welcome back, and in this clip we'll talk about the vertical figure of the particles. So till now we have covered this much section, and we have talked about the horizontal figuring of the particles, where you can see the random motion of the particles while flowing along the surface of this mesh. And we can also simply increase the overall lifespan of the particle. So instead of the 4, we can also go with the 6, so that we can simply maintain the continuous streak of the particles, and this is something really very important. All right, now let's talk about the vertical randomizations, or the vertical figure of the particles. And the moment we achieve this, you'll see a lot of change inside the overall physics of the particles. So let's go inside the expressionators, and here we have the n particle shape 1 dot goal v plus equals to 0.01. So let's do one thing, let's get rid of this thing, and let's write the same formula that we have, that is the we have the noise with the speed ran. Inside this we have the time plus the particle ID, and then close the bracket. Then we have another bracket and put that thing inside this, and multiply the whole thing with the amplitude, which is let's say 0.10 as if for now, and hit the option edit. All right, now let's do one thing. For the moment, let's disable the n particle 2. All right, now select the n particle 2 and hit the option this. Just make this disable for a while. Now if you just go back and play the timeline, you can see, okay, now let me do one more thing. Let me just enable the render type for the n particle 1 from point to the sphere. Now that's right. Now let's simply play the timeline, and notice this change inside the behavior of the particles. Well, that has to be there because we have actually introduced some fickle. So once we were doing the horizontal figure, then particle was just moving to and fro. So similar case has to be there inside the vertical. Particle also move in up and down, but we just want the particle to move only in the downward directions, a kind of a slip from the top to the bottom. So the particle shouldn't rise again upward. So we can fix this, and we have something very very nice over here. We can just introduce another function, that is the absolute. So absolute will return only the positive values. So that means it will simply cut down the negative values of the particle. So by negative, I simply means that what if we have the value of the particle this, it will go, let's say, positive 0.5 and then negative 0.5. That's the nature of the noise. Since I told you they return the value between the 1 to the negative 1, so the noise will give a random value, that is 1 to the -1, let's say 6 to the -6. With the ABS function, or the absolute function, we have only the positive value, and the good thing is that the moment particle is taking the negative value, it will just simply pause itself and then fall, and that will add more greater level of the physics inside the particles. Let's do one thing, let's make this happen. Let's multiply this with the ABS absolute and bring the entire thing inside a bracket. All right, now hit the edit. Now still we have one problem. You remember we multiplied the whole thing with the -1. Similar thing we have to do over here. So I do one thing, I'll just show you the result, then I'll get back. And here we are. So right now you can see particles are simply moving in the upward directions, and this is the way we absolutely don't want. So simply go over here and multiply the entire thing with the -1 value. All right, now hit the option edit. Now if we play, you can see we have a motion like this, and this is, I think so, something very very nice. But as you can see, the speed of the particle is really very high, but the good thing is also the particles are moving, and they are getting paused, and then again they are moving. So along the way they are sliding, they are taking some small pause, and then they are moving. All right, now let's do one thing, let's get rid of this behavior. Let's say we just reduce this value to maybe 0.50. I think so, that's nice, 0.050. And now if we play, you'll see a 50% reduction in the overall movement of the particles. But if it is fine or not, we cannot decide until unless we don't enable the n particle 2, because if there are suitable gaps inside the particles, then definitely we need to bring down the speed of the particles from top to the bottom. So let's select n particle 2 and let's say just enable them. And now let's do one thing. Let's get back to the point mode so that we can make some distinguish and hit the play. And here we are. I think so this is coming really very nice. You can see we have some really nice and interesting motion inside the particle, but still I can do one thing. Let's go over here and let's say the value is way too much high, so we'll give a value of maybe 0.025. and why should not we increase the frequency? Let's say we multiply this with a value of 2 and hit the option edit. And now if we play, let's see what we have. So we have something like this, and I think so this is really very nice. Now you can see the particles are pausing while they are moving and sliding. And if you think so that there is still some problem, you can definitely bring this down. Let's say we have a value of 0.015. all right, and we can also just increase this. So let's say instead of 2.5, let's say we have a value of 3. all right, now this way we can have some better horizontal fickle, and I think so this is absolutely nice. We don't need to do anything else. This is a really very nice motion inside the particles. all right, and now let's do one thing. I know that this is quite a tricky, guys, so if you are a fresher, if you are getting introduced to the noise or expression like this, then just do one thing. Treat the entire thing as a formula. all right, the moment even you miss a single bracket, you lose your control. Now this has actually gave me some problems because we cannot able to memorize everything. So the best solution is the consistent practice. Just make sure that you are not learning a technique, you are actually learning a formula. So noise, and again I'm repeating, noise is basically a function that bring you a random value but ranges only between 1 to the -1. Now the question is that we have already a range of the particle, that is 0 to the 1. So the noise either will give you the particle to the top positions or to the bottommost, or they can have some random values between them. So that's the reason if we just don't multiply this with a very small values of this amplitude. Now let's talk about amplitude. What exactly is the amplitude? It's the maximum distance between the crest and the trough, or you can say once you imagine the waves, so the topmost part of the waves to the bottommost part of the wave, the distance between these 2 points is the amplitude. So we have multiplied the entire thing with 0.0010. so that's the reason the particle fickle is way too much small, but there is a randomness, and this is due to the frequency we have and the value we have. all right, and I hope so it makes sense. Now you have understood the concept of the particle droplet effect. all right, and this has came up really very well. all right, so let's do one thing. Let's take a pause from this clip. We'll move to the next clip where we talk about the particle conversions. We convert this blobby particle into the simple polygon mesh. all right, so let's get started.